In this, let's see the different representation of a 3 address code. There are 3 ways to represent quadruples, triples and indirect triples. So first is quadruples. It is a structure which consists of 4 fields, namely operator, argument 1, argument 2 and result. OP denotes the operator and argument 1 and argument 2 denote the 2 operands. And the result is used to store the result of the expression. So let's take an example. Consider A equal to B into minus C plus B into minus C. So the 3 address code will be T1 is equal to U minus C. T2 is equal to what? B into T1. T3 is again minus U minus C. T4 is nothing but B into T3, that is this part is your T4 and this part is your T2. So T5 will be T2 plus T4 and this A is T5 is stored in A. So how we'll write? Hash column is there which contains the addresses, that is 0, 1, 2, 3, 4, 5. Operator, first operator is U minus, that is just individual minus. See, B minus C is a minus, but just minus C we denote it as U minus. Operand 1 is C, so argument 1 is C and result it is stored in T1, so result is T1. Then operator is multiplication, next operator is multiplication, argument 1 is T1, argument 2 is B and result is stored in T2. Next is again U minus, argument 1 is C, there is no argument 2, result is stored in T3. Then operator is multiplication, argument 1 T3, argument 2 B, result is stored in T4. Next operator is plus, argument 1 T2, argument 2 T4, result is T5. Next operator is assignment operator, argument 1 is T5, there is no argument 2, result is stored in A. So this is my representation for a quadruple. Next we'll see for triples. This representation does not make use of extra temporary variables to represent a single operation. Instead, when a reference to another triple value is needed, a pointer to that triple is used. So it consists of only 3 fields, operator, argument 1 and argument 2. Triples does not consist of the result field to store the space in the memory. So again take the same example, the 3 address code will be the same. Here only difference will be there will be no result. So we'll compare first. We have operator U minus, argument 1C, argument 1C. Operator is multiplication, argument 1 is T1. Now instead of T1, see here instead of T1 result you have a 0. So instead of T1 we'll write 0. And argument 2 will be written as it is, that is B. Again U minus, argument 1 is C. Then multiplication, argument 1 is T3. Instead of T3 we'll write 2. So instead of T3 we wrote 2. Argument 2 is B. So argument 2 will be B. Then plus, instead of T2 we'll write what? Instead of T2 we'll write 1. And instead of T4 we will write what? 3. So instead of T4 we wrote 3. And here in case of the copy statement, the last statement is what? The last statement is my copy statement. Operator will be assignment operator. Argument 1 will be the result, that is A. And argument 2 will be T5 corresponds to address 4. So it will be 4. So this is my copy statement. That is A equal to T5 is my copy statement. So in copy statement, what do? Result becomes your argument 1 and argument 1 of quadruple becomes your argument 2. Let's see indirect triples. This representations makes use of pointer to the listing of all references to computations, which is made separately and stored up. It's similar in utility as compared to quadruple representation but requires less space than it. Temporaries are implicit and easier to arrange. So here we'll see there is a list of pointers. First we have to make a list of pointers. So 0 is pointing to 14, 1 pointing to 15, 2 pointing to 16, 3 pointing to 17, 4 pointing to 18, 5 pointing to 19. Now we have to take the help of this triples table. U minus will come as it is, argument 1 will come as it is, multiplication. Now instead of 0, what is given here? 14. So instead of 0, just write 14. Argument 2b will be as it is, again U minus and C. Then multiplication, instead of 2, write what? 16. And argument 2 is B. Then 1 and 3, instead of 1 write 15, instead of 3 write 17. And operator will be plus. Again assignment operator, A will be written as it is, and instead of this 4, we have stored it in 18. So here it will come as 18. So this is the way we have to solve for the different representations.